Hello and welcome to the TMC Newsroom. My name is Rich Tehrani. Thanks for watching. We're in Las Vegas today at the Interop 2011 show. On our program is Dmitriy Ayrapetov. He is the product line manager at SonicWall. Dmitry, how are you?
Good, thank you.
So your company makes next-gen firewalls.
That's right.
And an obvious question is, what is the difference between a traditional firewall and what you would consider a next-gen firewall?
Sure. Traditional firewalls focus mostly on ports, on blocking specific ports. Next-generation firewalls rely on deep packet inspection, and they identify the traffic by what the traffic is, by the signatures by the application's signatures. They do intrusion prevention, they do anti-malware, they look inside of SSL traffic. So it's a much, much deeper level of security than what traditional firewalls can offer.
Now, in terms of speed, does that mean that network traffic is slowed down dramatically because of DPI and some of these other technologies?
That's a great question. So all of these DPI technologies take a big toll on performance. So one of the key challenges that we face, and that one of the things that we're providing to the market, is all of these services, but still at speeds that are sufficient to run from small businesses, medium businesses, up to large enterprises. But it's something that customers should be very cognizant of when they're purchasing a next-generation firewall.
And how does your company deal with that? Is it just faster processors and more complicated engineering to ensure that you don't have any latency or minimize latency?
So what we do is we have what we call a reassembly-free deep packet inspection engine. It's our own patented software engine, and we combine that with multi-core. And when I say multi-core, it's not 2 or 4 cores. We go up to 96 cores in a single appliance. And if you put a cluster of them together, that's 384 cores, and we can scale even beyond that.
Okay, so that would make sense. And you're using some state-of-the-art chips.
Yes, we use the Cavium Octeon processors.
Sure. I interviewed them yesterday, and they had 32 cores on a single.
That's coming up. Yeah, we're right now. Yeah, that's their next generation of the processors.
It's pretty amazing.
Yeah,
the technology.
Yeah.
I bet they generate a little bit of heat too.
Well, actually, I have to say we were very proud about the fact that our 96-core solution, using the Cavium processors, it only consumes 750 watts at 100% utilization.
Really?
Only 750 watts. It's 7.5 light bulbs.
Yeah, that's not bad at all.
It's we know that power, space, and cooling is actually a big factor in a lot of data centers.
Security. I mean, let's face it. The last 3-4 months, I mean, there were break-ins at Epsilon. Sony had a hack. I mean, the number of hacks, the list goes on and on, and those are the major ones that get reported. There are a whole bunch that don't get reported. There's so much incentive for people to hack.
Absolutely.
Because in many countries, there's not much of a penalty, and the rewards are so potentially huge. So I mean, it's crucial that companies are focusing on security and spending money where they need to spend it to ensure that they protect customer data, their data, because you don't want to be in the newspaper and on CNN and other news networks because you had a break-in. I mean,
and what those companies also need to focus on is that the break-ins today, the way that malware gets inside, and this malware then becomes a door into your network, is through application layer attacks, and that's one of the main reasons for next-generation firewalls to exist. Is if you're not looking inside the packets, if you're not looking inside the payload, browsers get exploited. Adobe Reader, for example, may get exploited. Adobe Flash, all of those are application layer attacks. If you're just focusing on stateful inspection, all of those attacks go completely under the radar for traditional firewalls.
Right, Google was hacked in China by as I remember, the Chinese government allegedly, or university, or the government, or depending on what news reports there were. I think it was the government that hacked into some of their computers to get into their network, and they did it via posing as friends on social networks and IM and things like that.
Well, it's even more nefarious than that. They used a maliciously crafted PDF file, so people don't associate PDF files with viruses. It was a maliciously crafted PDF file that was sent through email, and then that PDF file exploited a vulnerability in Adobe Reader and then planted the malware. So that was one of the vectors of attack into the network.
So there's so many vectors, and like you said, I mean, application layer is virtually impossible to predict in advance where you're going to have that attack, because as these vulnerabilities come out, a lot of times they are learned after they've been hacked. So you've got to come up with other ways to prevent those sorts of things.
So what we do, for example, for this specific scenario is there are general attack patterns that are that are similar across the board. So whether it's vulnerability in one software package or another software package, they look very similar. So we look for those patterns and we stop them at the gateway. So we don't even give the attack a chance to attack the software that's vulnerable to the attack. So we have a way of abstracting away from the specific vulnerabilities for specific software and start looking with our intrusion prevention, with the next generation firewall technologies, looking at those patterns and blocking them at the gateway. And very often, again, this particular attack, the vendor may just learn about it, they're working on a patch, but we already block it because we're doing it at the gateway and we're looking for a pattern of attack.
Now you have news at the show. I was hoping you'd tell us about what's happening.
Absolutely. So we have three major announcements. So one is, last year we announced Project Supermassive. This is the 96 core next generation firewall. Well, this year we're actually launching the products with it. We're proud to announce that we've shipped revenue units with these products. These are our top of the line, high performance, 10 gig, 20 gig, 30 gig capable next generation firewalls. So Project Supermassive, the E10000 series. We're also following that up with a SonicWall NSA E8500. The E8500 is our 10 gig capable next generation firewall, but it's in a smaller 1U format. We're also launching a new product line, actually, WAN acceleration. We identified that there was a gap in the market for WAN acceleration products for distributed networks and for SMBs. There are many WAN acceleration products out there. Many of them are very complex to deploy or are very expensive. But there are customers who can't deal with the complexity because they might not have dedicated IT staff or they may not be able to afford the products. Whereas at the same time, they can definitely benefit from definitely use the benefits of WAN acceleration. So we're launching a product line to integrate with SonicWall firewalls. The SonicWall firewalls are already very prevalent in distributed networks. So these WAN acceleration products will plug in with the SonicWall firewalls for very easy deployment and then provide WAN acceleration to those networks.
Are there any advantages to having the firewall integrated with the WAN acceleration box?
There are several, but I think the one that I think is the most important is the fact that the firewall gets a chance to look at the traffic and decide whether or not it needs to be accelerated or not. And if the traffic needs to be accelerated, then the firewall sends it off to the WAN acceleration device. If it's traffic that doesn't need to be accelerated, it just passes through. Whereas if you have an inline WAN acceleration solution, the WAN acceleration product has to cope with all the traffic that it accelerates, but also with all the traffic that it cannot accelerate. So by offloading this decision making to the firewall, we get better performance as a system overall.
Perfect. Thanks so much for being on the program.
Thank you very much. Thank you.